Putala, good afternoon.
Good afternoon.
So, before starting the sessions, so today's lesson 1, and today 20th November 2021. So, welcome to Thermodynamics class. All the 3 batches, 202 B2 semester 2, manufacturing, mechatronics, and I believe BST also will be joining. That's why I put an even I send the invitation to BST coordinator as well. So we will see, but I noticed that manufacturing, they have joined, mechatronics joined, and I can see BED. Puta, BED, you are under the manufacturing or mechatronics?
Mechatronics.
Mechatronics, very good. Okay, so how many BED students?
From manufacturing 1 and mechatronic 1.
Mechatronics 1. Okay, very good. So we will do some preliminaries today. So manufacturing, we have Nuan is the representative. Nuan, are you there, Puta?
Yes, sir.
Okay. So how many
Yes, sir.
manufacturing students are there in your batch? Active students?
Maybe 15 students, sir.
15. Okay, 15 approximately. So manufacturing. So Nuan is the batch, right? So you have some responsibilities, Puta. So when it comes to mechatronics, so mechatronics, who is the representative? Is the representative there? Mechatronics representative? Is the representative there? Not clear.
Umesh, I'm here, sir. My name is Umesh.
Umesh, are you there?
Sir, now it's okay?
Yeah, now looks okay. Eh? Yeah. So, Umesh.
Yes, sir.
Okay. So, Umesh Jairang. Eh? Okay. So, Umesh is there. So, how many mechatronics students, Puta? Just text me. Let me see. Yeah, how many students? The active students, mechatronics, how many with that approximately or precisely? Umesh?
Yes, today. Yes, sir.
19.
19 students.
Total
Yes, sir, today.
registration.
Only.
Total 19. Active
Not, sir.
students.
Totally 32 students
Total 32
at
students.
that moment, sir.
Okay, at that moment. Okay, very good.
Yes.
So we have manufacturing and we have BED1, one student. Is that so? BED1. So let me check with Hey Shani, Puta me
Yes.
BED mechatronics 1 student and manufacturing 1 student. Is that
Yes,
so?
sir.
Okay, very good. So BED1, mechatronics 1 is Meshan. BED1. So very good. BST. 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 So no one joined today. Maybe sometimes the communication issues maybe. But the BST coordinator, madam, talked to me. They also supposed to join, but we'll see. We'll see, don't worry. So this is basically the current, the students. Nuwan Puta manufacturing. So is this 15 is total? The total active students? Maybe, yeah. Okay. Give me the figures afterward. So today you can see 37 participants. So anytime you can send me your attendance, but of course after attendance, you should stay with the class. Yeah. So that is very important. So let's start the subject. What's the subject name? Thermodynamics. Thermodynamics. Thermodynamics is a very important subject. I think very important means the most, I would say, the most important subject you are learning, the thermodynamics. And the real thermodynamics, you will not see in the books. Okay, real, because there should be some use. There should be functions. Okay, there should be applications. So real thermodynamics always are with the nature, with the industry, within us, its function. Okay, so this is a very, very important subject, extremely important subject. Maybe attendance you can send me late, otherwise I have to open the chats. Yeah, no need to send now, so it's disturbing. Yeah. So maybe last, before winding up the class, you can send the attendance. So this is something like extremely important subject. Yeah. So take it to the heart. This is extremely important. So no words to say. And this is a must-know subject. Yeah. This is beyond the books. Extremely important. Important. Extremely important. Imagine if I say extremely important, and if you gain this knowledge, it is extremely valuable and useful to you. The same way, if you lose this knowledge, or if you do not gain, or if you didn't gain this knowledge, so you will lose a lot of opportunities. Even a lot of opportunities in your career-wise, and a lot of opportunities in understanding the others. Others means not the people, the other subject areas, other fields. So thermodynamics is very, very important. No two words to say. So I'm happy to teach you thermodynamics, but this teaching is a challenge. Okay, this teaching is a challenge because traditionally, we are having the classroom lessons all the while. So mechatronics, this is in this degree program, this is your first chance and the last chance of learning thermodynamics. And this may be, let's say, 44 to 50 hours of learning. So you have to make sure somehow with this learning, you can make use of this knowledge. That is very important. And this is not for an exam. Okay. I don't bother about the exams for you. I need you to receive some very good thermodynamics knowledge for the benefits for you, for your family, for your society, and also for the future generation. Yeah, learning thermodynamics has that value. Understand? And you cannot limit this to book knowledge and for the exams and certificates. And that's how I understand thermodynamics, the value of this. So you have to keep it into your heart and mind, and somehow you have to learn this. So you should be ready to learn this. It is extremely important. So it is beyond the books and extremely important and immensely useful. Immensely. It's extremely useful for you and others. That's why, because of this use, it is important. So later we will learn what thermodynamics means, but this is very important. And you should learn how to see thermodynamics. How to see thermodynamics. Because thermodynamics we cannot simply see. See, you can see your phone. Okay, you can see your notebook. You can see these words. Okay. You can see the books. You can see the walls. You can see the ceiling or the roof in your room. You can see the chair, table, and all that. Seeing thermodynamics is different. But you should see the thermodynamics. So we are learning here how to see the subject thermodynamics. That is very important. And learning and teaching thermodynamics. So I'm teaching thermodynamics, you are learning thermodynamics. That's true. But in this learning of thermodynamics subject, because time is a constraint, there is a major portion for you to learn by yourself. Okay, there is a major portion for you to learn by yourself. We call it self-studies. So for your self-studies, I'm helping you. So I'm providing you this note. Okay. So you no need to look into anything, but of course you can. So this note, I'm emailing you. So you have to go through this note and you should try to understand this. Okay. You should go through this. You should try to understand this. And out of this note, I'm asking you to take some tutorials in the notes, and you have to do it as continuous assessments, and you have to pass these continuous assessments for me. You have to submit it. Okay, so this is your portion of self-learning. This is your portion of self-learning. Then you may feel that, oh, this lecturer or this teacher passing entire thermodynamics note and asked to do self-learning and do the continuous assessment. Then what he is going to do in this lessons? If you are learning thermodynamics, the textbooks. Yes, that's right. So I have to show you the subject. I'm doing that part. Okay. So I have to show you the subject and I'm trying to do that part. And this book knowledge, somehow you have to get learned. You have the internet, you have a lot of information sources. So even you can have similar notes in the web. So this book knowledge, you can easily get it. So that's why I'm leaving you this part. Okay, I'm leaving you this part. And I'm taking what is not in the books to help you to feel the subject. Try to make you very good. Okay, try to make you very good at this subject and to win your lives out of this subject knowledge. So I'm taking that part in the class. I'm sharing that part. And you have to do this part. So jointly, we are achieving the bottom line. The bottom line means the outcome, what we need. Okay. That is more than the competency of the subject. This is very important. Okay, so this is the approach. So I'm going to email this afterward so that you can have this note. You have free time, you have flexible times for you to read and go through this. Try to understand, and my lessons, my teaching would be very useful to you to understand this. Okay, so I'm giving this, and in return, yeah, you can send the attendance later, not now, Buddha. Okay, because otherwise I have to see the chat, because sometimes in the chat there may be other than the attendances, so I have to attend to the chat. So please don't send the attendance now. Send the attendance later. Okay, that is very important. So otherwise our focus distracts. In this note, it's very clear. Mass and energy balance of systems. These are thermodynamics. The textbooks says this nature of knowledge. Okay, so you go through this. Try to understand this. If you have problems, I can help you. Okay, I can help you. Okay, so that is part one. And then there is another part. Of course, there are tutorials as well. Let me make it a little bit bigger. So after part one, yeah, part three, I miss maybe part two. Part two is non-flow process. Okay, anyway, and all under part one. So let me start from the beginning. Yeah. Under part 1, the revision component is here. Let me take it here. Revision component. So please go through this because you have some prior knowledge of thermodynamics about heat transfer. You have learned in diplomas. So I'm very sure. So you go through this revision, but this revision is extremely important. Understand this. Then you look into the number 2, non-flow process. And number 3 is the steady flow process. And then number 4 is second law of thermodynamics. Number 5 is vapor power cycles. That's all. Okay. 1 to 5 is your syllabus. But if you are preferring more to learn, for self-learning, you can look into heat transfer. Okay. Then the fluid flows, heat transfer and fluid flows. Then some practical examples, you have heat exchangers as well. Okay. So here, only until the item number 5, you have to learn. Okay. It is quite interesting. The contents are there. Very nice. So 5. You have to look into the revision here first. Later I will send you the notes even. Later I will send you the notes even. Oh. Revision. Okay, in the notes. So you can see in this revision, you are going to learn a lot of things. Okay, you have to learn a lot of things. And related to this, even you can explore other books, okay, other knowledge from the web, and even some textbooks. So you gain this under this subtopics. Okay, revision. So later I will email you this today presentation as well. Okay, so this is the revision part. So you do this first. Okay, revision part. After that, under the revision, there are some tutorials. We have to do that, and I will select a few out of those tutorials as the continuous assessment for you. Okay, as the continuous assessment for you. It is very important. So today I will take only this one, and the continuous assessment out of the tutorial. I think you do not see that. Slides. So this is the first section, revision. So you can see all the items. Make sure you know everything. So this is like a checklist. So do you understand about thermodynamic systems? Do you understand properties? Do you understand what equilibrium means? Process and cycles. You go through it, you understand it. Okay. You understand it. And make sure you understand all. Okay. And you have to do some self studies for this case. Then let me go to your note. In the note, under the revision, there are some tutorials. So you must do this tutorial. So there are 1.10, 1.11 tutorials, just two only. Okay. So these two you have to do and you have to submit this. Okay. So this is your CA part. I hope you can understand what I ask you to do. So if I get this, tutorial, let me do this way. Let me do this way. I will. Give me a second, Buddha. Let me arrange this nicely. See thermodynamics. Plan based on revision notes. So steam tables. And then the other question, let's see. Yes, very nice. One day. And this needs the steam table for you. So whatever the properties you can look into. And the steam table, let me paste it. The complete steam table now I'll put here. The complete steam table. Thermodynamics properties. Okay, here you can see the properties of steam. See, saturated water and steam, superheated water and steam. Even there are tables about the ammonia and some refrigerants would be useful. Okay, so I will save this as CA1 thermodynamics. (2020) B2 MAN MEC BST. Today's 20 November 2021. So at the end of the class, I will email this CA to you. Okay, I will email this CA to you, and all here information. So you can use this. Okay, all SI units. So this CA confirms that you have done something. Okay, so these are your, yeah, now we can see 40 plus participants, 42. So doing this, make sure that you know what's in the text. Okay, so whatever unknown, you are free to explore. Okay, you are free to explore. And if there are difficulties, you can check with me or you can discuss somehow. we have to look into the answers. Okay, and so at the end of the session, you can send the attendance later. Really, I just asked from you, so I cannot ask again. Eh? So you are come here not to put the attendance, but the priority is to follow the session. Eh? So afterward, you can send me the attendance. Otherwise, it's a bit distracting, sending attendance all the while. So that's it. So today, this is your part you're supposed to do. So this is mutual, okay? Because I have to do some important lessons for you, and I must have the time for those. Okay, I must have the time for those. So if I do this one, I will not find time for those. Okay, that's fine. So doing this is very simple. You can do this. Yeah, I leave it to you. And later we will discuss whatever difficulties. So today, the material means the learning material. You will be received after the class, okay? After this session. The first thing is this PowerPoint note we are building together. So you will receive this. Then after that, you will receive the note. What note? Thermodynamics. Dedicated for your module content. In the syllabus. Okay. So focused until chapter 5, section 5, as I mentioned there. So you will be receiving this as well, the note. And then you will be receiving the first CA with property tables. CA, first CA, and the thermodynamics property tables. Okay, together for you to use throughout the course. Okay, thermodynamics property tables are there for you to use throughout the course. Good. So any more I promise today? So other than this three, the note, the first C, the PowerPoint, and the fourth one, I will open up a Google Classroom for CA submission. Okay, so I will do that. And this one, the first CA, CA submissions. You may notice that the CA1, tutorial 1, this is from your note, okay? And tutorial 1B, have 2 sections, not more than that. So CA, so the tutorial 1A by the 27th means next Saturday. Okay, and tutorial 1B after next Saturday. After next Saturday means you want cover the dinibuta Saturday after next, yeah, in 2 weeks time. So this is 1 week. December 4th. Okay. After next Saturday after next Saturday. Okay. 4th December. After next week. Good. Puta prashna teenada. Any questions? Any questions? Any questions? Do you have any questions? Any concerns? Hey Shani, Puta prashna teenada. Any questions? No, eh?
Yes.
Yeah. So even B.Ed students, so they are going to teach our future generation. Yeah, that's why they are taking these lessons. Thermodynamics. So this is very important. So I mentioned that I have some part to share with you. So I cannot share those parts if you are not helping me with this. So that's why. So this is for the completion of the knowledge. So that's why you have to do this part. Okay. Learning. You have to dedicate some time, effort. Yeah, it is natural. Okay, so you have to put some effort. Yeah. So even for teaching, we have to put some effort too. Okay. So learning and teaching, both sides we have to sacrifice somehow. The time, the effort. Okay. So that's how it is. So this is your part. So this CA carry marks for your 40%. of the 40% of the marks of this subject final evaluation. 40% from CA, 40% from 60% from the year-end exam. So even for the year-end exam, the CA questions will be there. So this is very important. Okay, good. Yeah. Any difficulties we can learn? Yes, to submit the CA Puta, I mentioned to you that I will open up a Google Classroom for CA submissions. So I will do that. Okay, I will open up a Google Classroom. Or else you can email me, but I think you have some familiarity with Google Classrooms maybe. Don't worry, we will let this. But do it. Yeah. Even you can email me, that's all right. But in the Google Classroom, under your name and under your registration, the submissions are there. So it assures that there is no missing of the submissions. Yeah. So I will open up this a Google Classroom for CA submissions for thermodynamics. Yeah. Good. So today, the notes. So we thought of talking about this. The notes I'm passing to you. I have shown it to you. The first C, we talk about this and you have seen the C. Okay. And now you understand our teaching and learning approach. Okay. And now the next one is the chapter 11. Chapter 11 in my program here today. Chapter 11, you can see here, chapter 11. Give this name. Okay. Chapter 11. It's very interesting. And it is very useful for engineering and technology. This is to understand, to recognize, to see. Okay, what? Something very important. Okay, something very important. So, for this chapter 11 is inspirational. So I will refer that instead of explaining myself about myself, this chapter 11, my opinions. So I will refer chapter 11 for this. there is a story behind this chapter 11. Okay. This text is a translation of 2000-year-old text. This is a translation. Okay. So this should be translated later by someone, but 2000 years old text. The originality here may only be 20% because the Grandmaster wrote in a different language, different dialect. His thoughts put into the words, and those words were there in the chapter 11. And someone later tried to understand them. And based on his experience and understanding, he translated. There are, I think, around 82 chapters. So of this translation of chapter 11 is this. Okay. So I'm reading one by one. You will understand this in different ways. That is all right. Third spokes united around one hub to make a way. So, technology point of view, manufacturing point of view, learning point of view, you may have some understanding. Okay, there are a lot of meanings, similarities you can see. The second says it's the presence of the empty space that gives the function of a vehicle. Vehicle has many meanings maybe. But if you think of a car, a lorry, a bus, even a bicycle, this presence of empty space is very important for the function. Example, to drive, let's say the engine is there to give the pump. Piston, cylinder, assembly there. What is inside the cylinder? Nothing, just to accommodate the piston. So in the cylinder, the empty space gives the function. Understand? So the connecting rod joining the piston and the crankshaft. So you can see there is a free movement that helps moving the components, the free movements. Okay, connecting rod. At the piston end, there is a free movement. Actually, there is a space. Otherwise, there cannot be a free movement. And to assure the space, there are some lubrications or some other mechanical arrangement, but somehow the space is there. Connecting rod connecting to the crankshaft. You can see smooth turning there. Why there is a smooth turn? In that construction, there is a free movement. Okay. Inside the car, to sit, to drive, to accommodate the people, there is an empty space. Lorry, whatever. The space is something very important. Empty space we have to utilize. So the third one, clay is molded into a vessel, means let's say a small toy boat. It's the empty space that gives the function of a vessel. Let's say in a big container ship. The empty space, two functions. One is that empty space helps to float on the waters. And the same empty space helps to put the containers inside the vessel, big container vessels, utilizing the empty space. Not only that, in the ship designs, if you think properly, you can see it's a careful utilization of empty space. Doors and windows are chiseled out to make a room. Door in a room. Of course, you have a door to open and close, but the door functions when there is an empty space. Is open. Opening the door means the empty space is there for us to cross through. Windows for air to come and go, to flow in and out. Okay, so the empty space has the functionality. When you close the door, there is no door function. Okay. So the fifth point says, it is the empty space in the room that gives its function. Architect designing a house or room or interior design or even you. Okay, so when you are creating a room, actually there is nothing. It's an empty space. Just see your room. The four walls are their boundaries. What's within? It's empty space that gives its function. Yes. Therefore, something substantial can be beneficial, while the emptiness of void is what can be utilized. Means, as technologists, we should understand how useful the seeing of the empty space. Empty space you cannot see to your eyes. You have to see it from the mind. The mind sees the empty space. And then You do the creations to make use of that empty space for good. Yeah. So something substantial can be beneficial, means it is very helpful, beneficial when the emptiness of void, the space, that is we call space, can be utilized. So as technologist, when you are understanding some systems, solutions, technologies, whatever, everywhere, if you see the empty space, means you understand your system. Okay. Let's say you have a pen, maybe with your hand. Let's say ballpoint pen. Take the clip. If you think the functionality of the clip, inside what? Nothing. But there is a functionality. Then there is a piece coming out from the clip to clip it onto the shirt or a blouse maybe. Yeah, within that, the empty space that gives a function. Then you have a plastic, a stick-like thing. So what is that? It's nothing, just for you to hold. Okay, and inside the stick, there's a carbon rod. So if you take the carbon rod, by unscrewing both ends, you see only the space. In the carbon rod, you see the space to accommodate carbon. And if it's a ballpoint pen, there is a rolling tiny ballpoint. Okay, it's a tiny pin-like. Yeah, it's a sphere, a small tiny sphere. When you write, rolling over the papers, and the ink is coming through the gap. What's the gap? Gap is the space. Okay. So seeing the space and utilizing it, that is very important. And for a very good designers, for very good technologists, okay, you should see what the others don't see. Okay. And the mind sees it. The mind sees it. That's why your designs we call creativities. The creative designs. Because the mind sees it first. You imagine it. Then it comes to the drawing boards. And finally, for constructions and for manufacturing. Mind sees first. What mind sees first there? If you don't see the empty space, you are utilizing for good. Okay. You cannot be a good designer. So seeing the space is important. Okay. Understand? So I cannot share these things when I just meddling with the notes. Okay. So let me look further. Okay, let me look further. Maybe I will put some photos. So later you should be the designers. thermal flask. In your design, what is inside? Of course, here the water, they are pouring out, but in the original design, inside is empty. Why it's empty? For a purpose. See this cup. In the original design, what's inside the cup? Nothing. The void, empty space. So, handle. See the empty space here. If no empty space here, you cannot utilize. Utilizing the empty space, see, handle this. Even the threads, lids, whatever, wherever. Even the groove here to make this strong, maybe somehow you can see. You should be able to see this utilizing of empty space. Okay. This rice cooker, as you can see, rice is here. But in this design, what is this? Empty space. Even to put this, there is a space everywhere, using the space utilization. So you cannot see this physically, but your mind sees it. So you should be very skillful. Okay. So that's why if you don't see this, it is very difficult to understand technology, especially thermodynamics. A refrigerator. I think I will take a new slide. Section is in your original refrigerator design, all empty spaces, everything, even the insulations. There is a space or gap for the insulations. And even within the insulation, there is a huge empty space. That's what we call foam. So it's very true that something substantial can be beneficial while the emptiness of void is what can be utilized. So let me take that phrase out. Even this text box also originally it's empty. So we filled it with some words and colors. So utilize it. Something substantial can be beneficial, while the emptiness of void is what can be utilized. Something very effective, substantial, while the emptiness of void. Emptiness, void, same meaning, but the void is the void. Okay. So do you see this emptiness of void in your engineering applications? Do you see it? Do you see it? I'm very sure your previous studies in an engine, you have noticed the piston. See, you have noticed the cylinder, both. You know that the piston is accommodated into the cylinder space, but you never notice how important the empty space is. Even for coolants to flow. Even see here valves opening and closing. Yeah. What's the functionality? The gaps, the space, you are making use of this. Something substantially beneficial. See some, maybe for coolant and all, to flow through, to control the heat or to control the heat of the engine block, the coolant passages and all. Again, empty spaces. Have you ever seen this? So if you have not seen this, you are not creative enough. You cannot understand this. Okay, that's why for creativity, actually learning is to realize the creativity. See in the space. It's a must. Okay, see in the space is a must. So in all your thermodynamics notes, if you see something, a word called volume. Yeah. What's the volume means? The space. I think you have heard the volume, the word. It's related to the space. But you have not noticed that. That's the problem. Okay. So as long as you do not naturally recognize this, your learning is not effective and your learning is somewhat slow and your learning looks difficult because the way you are learning is not the way, not the right way you're supposed to learn. As learning, you are doing something different. Okay, that's why. So learning is not a joke. So nature's, the space is something, something an attribute of nature. Subhadhame gunamya, his power, space. So in all our solutions, it is necessary to accommodate the space. It is naturally there. And if you don't say this, you cannot be valuable teachers for BED and for technologists. You cannot be very good technologist if you don't have this nature sense. Okay, it is very important. So this attribute comes in thermodynamics as volume. sometimes as a displacement, sometimes it has a connectivity with density. Okay. Yeah. So you should understand this. So this is the first lesson today. See in the space. Okay, see in the space. It is very important. Understand? Udah തീർന്നാണ്? Hello. Oh, miss. Oh, miss. Oh. Ano, miss. Nan තියෙනවා මන් තියන්නද පටස් ගාලා. හරිය තාමත් තියෙනවා very slow. Do you understand? Do you understand? Okay. Somebody says. Okay. This is again utilization of empty spaces. I just got this. When I see this, I know that the space is being utilized. Now that is very important. Space has a very important function in everything. Okay, good. So give me a second. The next one. Matter and space. Yes. I think you have agree with this. Matter needs space. This is a very general say. Matter needs space in general. For our beneficial, practical usages. Matter needs space. Matter needs space. Matter needs space. It's a general saying. But for black holes like things in the universal, there may be matter with no space. There may be, but for our case, most of the applications, matter needs space. Let's say what? It occupies space. Occupies space. What? And then the soil again occupies space. Occupies space. Air. Because these are very important. Nature's things. Occupies space. Space. Then the stones occupies space. Moisture occupies space. Yes. Everything. Blood occupies space. Okay. Occupy space. Okay. And very interesting. Water occupies space. So glass facilitates the space. So we have a glass, it facilitates the space. Soil occupies space. Okay. So even there can be some molds. Let's say these are the practical application molds. Say soil mixed with soil or sand. Okay. So there are some maybe applications that occupying spaces. Air. It's air compressors. Compressor. Cylinders. Occupy space. Stones. Let's say dump truck. Occupies space. Wall. Facilitates. So these are facilitates and make something useful. Moisture. Moisture. Occupy space. So moisture in the air. So blood vessels. Yes, facilitates blood flow. So it is more than occupying, so it lets the blood to flow as well. Interesting. So you have some facilitate to occupy the space, even the rice cooker. So first, it facilitates cooking. Okay, so the space the outlining, the recognition of space is important. So matter and space. So matter needs space. A general sense. But space doesn't need matter. For its space doesn't need matter for its existence. Matter needs space for its existence. Unless. So matter always goes with space. Okay. So matter always goes with space. Sorry about that. So this is the matter outside the matter. Because if this is matter, so to specifically recognize this, that should be outside the matter. So in thermodynamics, so whatever, we call this surrounding. Okay, this is surrounding. So the surrounding surrounding need some different colors. Surrounding, good. And then this is matter, this is surrounding. So the demarcation, the separation here. Is this. We call this boundary. Boundary. This is we call boundary. Okay. What is boundary? Let me put bound. So space here. So the space, the boundary of the space. We call this is the, another word is here for our matter of concern. We call this system boundary. System boundary. This is the boundary. So this matter, we call this, actually, this contains molecules, this contains atoms, and all are in motion. And there are some molecular level, atomic level. There is something like a system, we call this. Later we will understand why we call this a system. So this matter content, we call this system. And it is thermodynamics system. Okay, later we will learn it. So here, the matter, space, system, matter, space, surrounding, and boundary. So this matter within bracket I put system. So the boundary I put system bound. I hope you can understand this. You can make sense of this. System bound. Later, let me explain why this is called system. Okay. Why this is called system. We call system one way because considering this space. Okay. So some cases, space fixed, example in a rice cooker or in a thermo flask or in an engine, you can see the space and matter, but sometimes you may see that some cases, some matter goes outside. Example, in a rice cooker, the steam going out. Some cases comes inside. Maybe you put some extra water into the rice cooker. But rice cooker is rice cooker. That's why we call system. So when we use the word system means it is no matter. The matter goes in or out. We have something, a space of recognition. Something space of recognition in which the matter is there, and this matter even could be transferred or crossed through the boundary to the and to and from the surrounding. Interesting. Okay. So that's the reason why, other than the matter, other than the volumes, so we have to have this word system to recognize something. What we are considering is more than matter. It's a combination of matter and space. Okay, we call it system. Okay, we call it system. It's a combination of matter and space. We are thinking together. System. So space can be minimized, matter remains. Or matter can be changed, space can be remain unchanged. Or both can be changed, or both can be remain the same. So that's why this matter and space combination, somehow feel to consider this as a system. So the rice cooker inside, let's say the water boiling in a kettle. So we take it as a system. Even though it is single entity of water, we take it as a system. So you have to understand this. I think it is very easy. We start from the matter. Matter needs a volume. And the volume means the space here. Matter needs a space to occupy, which is called the volume. So matter, you have the mass and volume. Okay, mass and volume. Interesting. So mass and volume. So together exists. Mass and volume together exists. Can you see a little depth here? Chuti gamburak wage tiyanawane metana. Yeah. When you see it from your mind, you will see there is something substantial. Not like the grade 10 mass and volume. So now the volume relates to the space. When you see the space, seen the space and seen the volume, when you connect both, your knowledge is different. Understand? Your knowledge is different. It is not the O-level knowledge. It is not the A-level knowledge. It is something beyond that. Okay? It's not the way you learn O-levels. It is not the way you learn A-levels. Now, your learning approach is different. Okay? So you are seeing something unseen. You are seeing something unseen. It is very important. Okay. Still too early to send the registration numbers. So we will get the numbers later. Very good. So matter, space, surrounding, boundary. And one more thing appear here, system. Okay, system. So space. When you quantify the space, it is volume. When you quantify the matter, it is mass. Mass you measure in kilograms. Volume you measure in maybe meter cubes. Then when you have M and V, even you can have M by V as another parameter, means relative to the volume of the space. Relative to the volume of the space, the density. That's how the parameters are coming. Parameters are coming. Density. Interesting. And next week, we will be talking about the temperatures. So, for the moment, it is about the basic, the matter, volume, and the density. So, density is common to any size of volumes, irrespective of the volume, because this is the per meter cube, per unit space. Okay. So now you have to go through your notes and you will have more understanding. The way I'm sharing, it is not in the notes. Okay, so we have started learning this from space. Matter is familiar to you, and then the facilitating or accommodating matter. So glass facilitates the space to accommodate matter. We call them the glass of water. Okay, very nice. So you have to see everything, and you have to have total understanding. That is very important. Looking at the things, the phenomena. So you must have a different level of observations, different level of approaches. Okay, seeing something through the mind. So this is not memorizing. That's why memory is no knowledge. Memory is no knowledge. Memory has no knowledge. Memory is not the knowledge. Okay. Equation is not the knowledge. To me, equation is something like a word, expression. Okay. So before expressing it in words or equations, say thermodynamics, you should know thermodynamics upfront. If equations are not thermodynamics, then what is thermodynamics? You have to recognize it. You have to recognize it. That's why I'm telling you that some things that if he or she is good at mathematics, he or she can be good at thermodynamics. No such thing. Okay. If you cannot write equations, but still if you can write words, if you can understand, your thermodynamics knowledge should be very strong. Okay, that's the point. So there is no any prerequisite of strong mathematical background to learn thermodynamics. No such thing. Understand? I have not written any equation here. Okay. Equations cannot explain thermodynamics, but your mind seeing the things can explain thermodynamics in words. To me, equations also seem like words. Okay. When you know the words, when you have the good understanding, writing an equation is writing a sentence, not a big deal. So you no need to be a great mathematician, or you no need to have the mathematical skills, but good to have some maths. Okay, so good to have some maths. It's a different story. So you all are qualified to learn this subject, to unfold the secrets the nature is keeping. Okay, so to unfold these secrets, you are here for that purpose, to see from the mind what we are gaining when knowledge has thermodynamics. Okay, later we will understand more about this, because I'm not asking what's the meaning of thermodynamics, because thermodynamics, the subject has some universal aspects. Okay, so don't get your definitions and limiting the subject. No such thing. So don't worry about the definition. You have to learn this very well. You have to see the subject very well. So that's why we have two-way approaches I gave you a part for you to learn by yourself. If I do that for you, I have no time to share this with you, to improve your thought process. So when I cannot improve your thought process, and if I use the same note to explain to you, you will not learn thermodynamics. Okay? You will learn rubbish. Maybe you pass the exam, but no use for you. Okay? So that's why this is a quite challenging subject. It's a very good subject. It is very important. So immensely useful, extremely important, as I mentioned to you. So we need two ways. So you have to help me by learning. Okay. I'm helping you as well. So extremely important, immensely useful. So you should learn how to see thermodynamics. Now you have a sense that we should learn how to see thermodynamics. And you have realized that this is beyond the books. The experience teaches. Okay. Now you may realize that in the very first subject slide, what I mentioned, these 4 points are correct. Okay, so I'm helping you for this aspect to gain some very good, useful and beneficial knowledge. And also to make you a little bit, not to say philosophical, but to have some good understanding. It is very important. So before winding up, let me put the final 2 slides. It's 328. There are something we call working fluids. Means the fluids are working. Fluids are working. Fluids have functions. Okay? Fluids have functions. This is a blood vessel through which the fluid flows. So you know how critical the blood flow. Same way, the working fluids, steam is a working fluid. When the working fluid flow stops in steam flow, in some applications, the functionality stops. Example, steam turbine. If steam flow stopped, turbine stops. Same way, in your body, if the blood flow stops, what happens? The body function immediately stops. Then heart attack, what's the causing the heart attack causing deaths means the heart attack. The heart stops, blood flow immediately stops. No function. Okay. So working fluid, even in refrigeration and air conditioning, through these systems, the working fluid, maybe refrigerant flow through. So we call it the working fluid of refrigerant. So different stages, different functions. Okay, different functions. performed by the same fluid. So that fluid flow is important, and that fluid flow is working. So you may come across sometimes this word working fluids. So if you need to look into working fluids, think about this. Even in our body systems, this working fluid, this network is a mystery. A mystery. Yeah, we are so-called developed, but we cannot produce blood. Not possible. Nature's the mysteries. Very important. Actually, from you, within you and me, we can learn maybe more than 50%, maybe more than 100% thermodynamics. Do you know that there is a fire within us? What is fire? What fire produces? Heat and carbon dioxide. ගින්දර කියන්නේ. ගින්නකින් ඇති වෙලා finally the fire. After fire, you have the heat, you have the carbon dioxide, and there may be light as well. Even our bodies, even we exhale carbon dioxide. Our body produces heat. And for the combustion, needs oxygen. So in oxygen, environment, combustion takes place. We also take oxygen. So then we breathe in oxygen. We breathe out carbon dioxide. So something biochemical reactions takes place. It is same like a fire within us, and we keep it warm. Okay, and it makes the body warm because of the fire. Even now, the latest biotechnologies, they are going to tap energies in the bodies to run some biomedical devices within us. Of course, there are some mechanical gadgets, the electrical, mechanical, some nano-level gadgets are powered by the body's energy itself. Okay, so thermodynamics is very important. In the weather, you see thermodynamics. Global warming, you see, you can address global warming in terms of thermodynamics. Cyclones, you can address in terms of thermodynamics. Undersea currents, you can address in thermodynamics. Okay, and this is even the rocket propulsion, engines, turbines, power generation, power plants, even your household applications, everything. Wherever the heat is there, the power is there, the thermodynamics is there. So this is very important. So it is 4:35, sorry, 3:35 now. We have to stop the class, Putala. So I have saved the attendance. Anymore, just send me, I will save it. So you have to learn this subject somehow. Okay, there is no limitations, no boundaries, and it is impossible to learn everything. Maybe in 100 years time, there may be some added new knowledge for this subject. Even in the manufacturing of your mobile phone, your computer, these displays, it's a huge thermal application to produce LEDs, semiconductors, transistors by using this, we call the silica. It's a huge thermodynamic process. Applications, enormous. Food engineering, food technologies, all thermodynamics combined with food sciences. Okay, good. So explore this subject to the fullest, and this is a central technology, a kind of science that everyone should know. Okay. extremely useful. So later we will learn some more. You have your own role to do in this learning process. Okay. So you are doing some self-studies. I'm going to send you the notes now and the CS as I mentioned to you. Okay. So these are the things. So the tutorial 1 next Saturday. After next Saturday, the Saturday after next Saturday is the tutorial 1B. Okay. Good, Putana. So I will send this note to you as well. So today I will deliver this to you after the session. So thank you for joining the class today. And I have a little issue. I have to mention it to you. Since today is the first day I took this lesson, but at the same time, I have another lesson as well. For your seniors, it's a different subject. Today I skipped that lesson because I took this very first lesson with you. So sometimes I have to change this class timing, or I have to change your seniors class timing, because two classes same time, that is not possible to make it. Okay. So if possible, propose some different timing, that is very good. Otherwise, I will discuss it. Both the classes, your class and the seniors, and somehow we have to shift one class. Okay, Bhutana? Yeah, because this time there is a clashing with the other timetables. Thank you. So thank you for joining the class today, all of you. Are there BST
Thank you, sir.
students? Yeah, Bhutana. Are there BST students here? Not it seems. They also supposed to join. I don't know. Anyway, I have sent the timetable to the coordinator. Sorry, coordinator madam. So, but anyway, we will proceed the class. So, learning thermodynamics, you can learn everything. Yeah. So, there should be some specific ways of learning. So, you have a big role, same like my case. Okay, Buddha. So, I'm expecting all of you to join the class daily because you will be learning new things. So, that is very important. So, I will make the class interesting and useful to you. So you do your part as well. Thank you. Then take care, all of you. See you Buddha next week. So thank you very much for joining the class. And good luck for your Institute learning efforts. Thank you. So bye for now and see you next week. Bye then.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, thank you, Butala.
Thank you very much, sir.